Warm up for lesson 7-5. Let's take a look at the two functions, the exponential and the logarithm, and notice that they are inverses. Now, before, when we found the composite of inverses, we ended up undoing each other. So if f of x is 3 to the x and g of x is the log base 3 of x, f of g of x, remember where f is the outer function, so we're going to use this outer function, put a parentheses in for every x, and then inside that function we're going to write the inner function, and then these will undo each other and you'll just have x. If you have g of f of x, that means g is the outer function, so here's the log, and we'll leave a parentheses, and inside the parentheses we're going to put the f of x in there, and these two will cancel each other out and we will get x. All right, let's go ahead and simplify. 3 to the log base 3, these undo each other, so we'll just get 5. These will undo each other, an exponential and a log inside of it will just give 3. A log and inside an exponential will just give 7. They will undo each other and we'll just get the 7. And the same here. I'm going to stop here. You finish the 4 problems and then go ahead and continue. And here are the answers. Lesson 7-5, Properties of Logarithms. The objective: simplify and evaluate expressions using the properties of logarithms. Solve logarithmic equations using the properties of logarithms. Let's go ahead and take a look at our first property. First, let's go through this process here to discover the property, and then we'll discuss it a little in more detail. Okay, so right now we're going to say a is equal to b to the x, c is equal to b to the y. So we're going to multiply these two, that's going to be right here, and we're going to multiply these two, and that'll be on the other side because they're equal to each other. We'll use the exponential laws, and we'll have b to the x plus y. And now we're going to take log base b of both sides. So we have a log base b and a log base b on both sides. Now this is going to be an inverse process, and they will undo each other and you'll just get x plus y. And then we have this expression. Now remember what x is. X is, if you change the exponential into a log, then the exponent x will be equal to log base b of a. And if you isolate the y here, y will equal log base b of c. So we have some new ways to write x and y, which will be written right here. So it looks like when you have the log of a product, it's the sum of the logs. And that's the property right here. The log of a product is the sum of the logs. So the log of a product, you can separate it by log base x of a plus log base x of b. All right, so here's the property right here, and we're going to use the property to go ahead and figure out this expression right here. So we know 125x is really 5 to the third power times x. So it's a product like a times b. So we can separate them. Log base 5 of 5 to the third plus log base 5 of x. And these will undo each other to create 3. And we have a value for that that's right here. We're going to put it in and we're going to get this answer. Okay, let's practice a little bit more. I want to figure out log base 4 of 32. Now I know that 32 is 2 times 16. So this is a product like a and b. So I am going to separate them, and it'll be log base 4 of 2 plus log base 4, and we can write 16 as 4 to the second power. Now this, we're already told, is 0.5, and these will undo each other. A log and an exponential of the same base will undo each other, and that'll be 2, and so the answer is 2.5. That was the answer I was trying to go for. Okay, your turn. And here's the answer. 96 is actually 32 times 3, and 32 is 2 to the 5th. So I have this product A times B, and I separate them, simplify, substitute, and I get my answer. All right, let's take a look at another property. Let's go through the proof first before we actually look at the property. Again, I have two expressions, A and C, and then when I change them to their log expressions, remember the X will be isolated, and it'll be log base B of A, and then if I get Y by itself here, I'll have log base B of C. So I'm going to take these two expressions and divide them, and then this is showing A divided by C. Now I'm going to use my properties, my power properties, and get this. I'm going to take log base B of both sides, and when I do that, I have an undoing process right here. We have inverses here, so I can just write X minus Y, and I'll leave this here. Now I'm going to substitute for X, because X will equal this, and Y will equal this. So in words, this says the log of a quotient is the difference of the logs. So the log of a quotient is equal to the difference of the logs. Let's go ahead and use that. I have log base 3 of X equal to this, and I want to approximate the value of log base 3 of X over 3. So this is like A divided by B. And so I know that the log of a quotient is the difference of the logs, so I'm going to separate them. I know this answer is 0.7925, and these will undo each other, and you'll just have 1. And then when I subtract, I will get this answer. All right, let's go ahead and find the exact value. Since they both have the same base, this will be log base 4. And I'm going to take both of these, 24, and divide it by 6. So the difference is dividing. And then this is going to be log base 4 of 4. And I know that simplifies to 1. Now this will be log base 5. And it's going to be 1 over 25. And that's the same thing as log base 5 of 5 to the negative 2 power. These undo each other, and therefore the answer is negative 2. This will be log base 3 of 3 over 27. So this is log base 3 of 1/9, log base 3 of 3 to the negative 2 power, and these undo each other, and we get negative 2. Log base 2 of 1 over 16. This is log base 2, and this is going to be 2 to the negative 4 power, and they undo each other, and we get negative 4. Okay, our last property goes like this. The logarithm of a power is the product of the logarithm and the exponent. Okay, so right here is the log, and this is the power. And it says that that is going to be the product of the exponent times the log. All right, let's go ahead and use that property right here to approximate log base 2 of 25. So log base 2 of 25, 25 is 5 to the second. And this is an exponent, which I can bring over here to the side. That's going to be 2 log base 2 of 5. And since I know log base 2 of 5 is this expression, I can multiply. Okay, let's go ahead and do this problem. Log base 3 of 49, and 49 is 7 to the second power. Now, remember that the log of a power is equal to the product of the power times the log. So I'm going to write that as 2 log base 3 of 7, which is going to be 2 times, and I have an approximation, and I'll let you do the rest with your calculator. Pause to see if you can do the problem. And here's the answer. Let's take a look at solving equations with using the properties of logarithms. So we're trying to solve for x. The first thing we'd like to do is see if we can get these together. And I know that when I have a sum, I can go from the sum to a product, and here's a product. The sum goes to a product. Okay, now that I have one log expression, I'm going to change it to exponential form. So here's my base, here's my exponent, and then here's my argument right here. Okay, now I know this is a quadratic. I go ahead and factor, I solve each. Now we're going to have to try to put 12 into each one of these to see if they work. And if you put 12 in there, you're going to get it to work. Now, if you put -3 in over here, you're going to have a -3 inside the argument, and that's no good. So you don't have to worry about that. That's an extraneous solution, extra solution that does not work. Okay, let me go ahead and do this problem. This is going to be log base 7 x to the second power. So I'm bringing this up to the power. I can go back and forth on it. Now this is a sum, so I'm going to write log base 7 of 27 times 3. Okay, I notice that I have the same base, and so these two logs are equal to each other. That means their arguments are equal to each other. So x squared is equal to 81, and therefore x is equal to plus or minus 9. X is equal to 9 or -9. Now I can see if I put -9 in here, I'm going to get log base 7 and -9. Remember that this can never be negative, so this is not a possibility, but 9 can go into there and it will work. Pause, see if you can do the problem. And here's the answer.